So now I am going to start a series of practical chemistry or analytical chemistry. In that I will be starting analytical organic chemistry and analytical inorganic chemistry. So this is the first class of qualitative analysis of organic compounds. So first we will learn identification of organic compounds. Organic compounds can be of two types. They can either be solid or liquid. So first thing that we have to determine is the melting point. In case the organic compound is a solid, and if in case the organic compound is a liquid, we have to determine the boiling point. So I will not be showing you how we measure the melting point and the boiling point. For that I will be making another video in which I will be demonstrating how to take the melting point and the boiling point. In my synthesis of TNT, I have showed taking out melting point, so you can check out that video. So the next step after taking out melting point is solubility. So solubility of organic compound, this is generally done in case of solids, because in case of liquids we don't call it solubility, we call it miscibility. Okay, so how you check the solubility? First we have to check solubility in water. If the substance is soluble in water, it could be an aliphatic acid, a phenol, alcohol, or it could be an amine also. Mainly aliphatic amine. Okay. The next step we take is sodium bicarbonate solution. It is generally 5%. We check the solubility in sodium bicarbonate solution. So if the compound is soluble in sodium bicarbonate solution but insoluble in water, it could be an aromatic acid. Then if our compound is insoluble in both the water and sodium bicarbonate solution, next we check the solubility in 5% sodium hydroxide solution. If the compound is soluble in sodium hydroxide solution, it means some sort of phenolic compound is present. Not phenol, because phenol is soluble in water. It could be naphthol or some heavier phenols which are insoluble in water. Okay, so these compounds are soluble in 5% NaOH solution. The next, we check the solubility in dilute HCl. If the compound is insoluble in all the three but soluble in dilute HCl, it means it could be an amine, most probably aromatic amine, because mostly aliphatic amines are soluble in water. Yes, और कुछ तो नहीं था. हाँ ये चार्ज शायद. ठीक है. So after we have completed our solubility test, we can predict the nature of the functional group present in our organic compound. The third test is the ignition test. So what we do in the ignition test is we take a small quantity of compound in a spatula and burn it in a Bunsen burner, and we observe the flame. If the flame is sooty, if sooty flame is observed, the compound could be an aromatic compound. Then we come to the fourth test, which is the unsaturation test. In unsaturation test, we take a small quantity of compound and add aqueous KMnO4 to it. If the color of the KMnO4 is discharged, it means that the purple color of KMnO4 is turned brown or turned colorless. It means the presence of unsaturation. If color is discharged, it means a double bond or triple bond is present in our compound. But in some cases, this test becomes also negative. Means it's given in some cases, some compounds which are not unsaturated also give the KMnO4 test, such as phenols. Phenols can get easily oxidized by aqueous KMnO4 and give a fake positive test. Okay. Amines also, aromatic amines also give this test positive. Then the second one is bromine in CCl4. So what we do is first dissolve the compound, dissolve the small quantity of compound in CCl4 in a test tube, and then to it we add bromine and CCl4 solution into it. If the brown color of the bromine is discharged, it means it becomes colorless, then the test is said to be positive. Okay, and only if both the tests are positive, only then we say that our compound is unsaturated. Otherwise, even if one test is positive but another is not positive, we don't say that our compound is unsaturated. But in some cases, bromine water test is also bromine in CCl4 test is also given falsely, like in the case of aromatic phenols, because they form a bromo compound with bromine forms the bromo compound with phenol, and also aromatic amines. So these are some compounds which can give a fake unsaturation test. Magnase test, which is also known as the sodium fusion test. This test is done for the identification of different elements or the heteroelements such as nitrogen, sulfur, chlorine, bromine, iodine and fluorine. Okay, so for this test we have to prepare sodium extract. It is done by fusing the organic compound in an ignition tube with sodium metal, and then after the extract is ready, we have to dissolve it in water, and then we have to boil it, and then we have to filter it. So what happens in this test is whatever the organic compound is present, it forms a salt with the sodium metal, such as if nitrogen is present, sodium cyanide is formed in because organic compound already contain carbon, so therefore carbon is provided from there. So sodium cyanide is formed in the presence of nitrogen. If nitrogen and sulfur both are present, then sodium thiocyanate is formed. If chlorine is present, then sodium chloride, bromine is present, then sodium bromide, iodide and fluoride. In this way, salts of sodium metal are formed. Okay. Now, how we do this test? After we have prepared the sodium extract, we divide the filtrate into 4 parts. I will make a separated video on preparing sodium extract. Okay, for that you don't worry. Then we have divided the filtrate into 4 now, into 3 parts. Now we take the first part and acidify it with dilute sulfuric acid and then add ferrous sulfate solution in small quantities. Okay, so we have to add ferrous sulfate solution drop wise, not in excess. Now we come to the observation of this test. If blue color is observed, nitrogen is present. Also, I have to mention over here that hydrazine does not give this test because carbon is absent in hydrazine, and this test requires carbon to form this sodium cyanide salt, which forms Prussian blue. Due to Prussian blue, this blue color is observed when it reacts with ferrous sulfate solution. Now, if blood red color is formed instead of blue color, it means that nitrogen and sulfur both are present, because then sodium thiocyanate is formed, and when it reacts with ferrous sulfate, it forms a blood red color, because the ferrous sulfate that we use is not pure. It has both ferrous and as well as ferric ions. Then after we have performed this test, we come to the second part. Now we have to acidify the second part with dilute nitric acid. We have to acidify the second part with dilute nitric acid and then add silver nitrate solution. So after adding silver nitrate solution, precipitate may be formed. So if the precipitate is brown or black in color, it means sulfur is present. Now it can happen that sulfur and halogen both are present in our organic compound. So the formation of this brown or black PPT will hinder the observation of other white or pale yellow precipitates of halogens. So for that, to remove this brown PPT, we can boil the precipitate in nitric acid. So this will oxidize the silver sulfide, and then we can test for other halogens. Now, if Cardi white PPT is formed, which is soluble in aqueous ammonia, chlorine is present. If pale yellow precipitate is formed, which is soluble in aqueous ammonia, bromine is present. If pale yellow precipitate is formed, which is insoluble in aqueous ammonia, iodine will be present. Bromine and iodine can be determined by chloroform test. Okay, so I will if you are unaware of this chloroform layer test, you can watch my test on bromide ions and iodide ions. In that I will show you how to perform chloroform layer test. Okay, now we come to the third part. So in third part we will be testing for fluorine. So in this case we have to neutralize the third part with acetic acid. Keep in mind we have to neutralize and not acidify, because if we will acidify, our test may become negative in the presence of fluoride ions. So we have to keep the condition almost neutral. So that's why we are over here using a weak acid like acetic acid and not a strong acid. Then we have to add calcium chloride solution. On adding calcium chloride solution, white PPT of calcium fluoride will be formed, which confirms the presence of fluoride ions. Okay, so this was the Lasagne's test or the sodium fusion test. Okay, now we have to perform the function group test in the same order as I have written over here. So first we perform the test for acid group, which is the carboxylic acid group. COOH group. So we add sodium bicarbonate solution to this organic compound in a watch glass, and if we see CO2 gas bubbles or we hear some fuzzing sound, then we can infer that carboxylic acid group is present in our compound. Then after we have tested for the carboxylic acid group, then we test for the aldehyde group. So aldehyde is tested by the Tolles test or the Fehling test. Then after we have tested for aldehyde, then we come for the test for ketone. So ketone is tested by 2,4 DNP test. Okay, the 2,4 DNP test is, the full form of DNP is 2,4 dinitrophenylhydrazine. This test is also given by aldehydes, but in so it's important to first test for aldehyde and then test for ketone. Now we come to the ester group. So to check for ester group, we take the compound, add few drops of sodium hydroxide solution into it and phenolphthalein into it, and then boil. If the pink color form disappears on boiling, it infers that ester group is present. Then we test for alcohol group. To check for alcohol group, we have cetic ammonium nitrate test. On adding cetic ammonium nitrate solution to an alcohol, it gives a dark deep orange color. And the potassium dichromate test. On boiling potassium dichromate with an alcohol in the presence of an acid like sulfuric acid, the solution of the potassium dichromate solution changes from orange to green. So this test is also given by alcohols, but it's important to first test for aldehyde, esters, and then perform the test for alcohols. Then we come to the phenol. The phenol group is nothing but OH group attached to an aromatic ring. So we test phenols by the ferric chloride test and the phthalate dye test. So over here I am not showing you that all these tests in detail. I am just making an introductory video of identification of organic compound. All these functional group tests will be uploaded on my channel further along with the demonstration. Then we come to now we come to the amide, amine, and nitro group. So first we only have to perform this test only if we have confirmed the presence of nitrogen by the Lasagne's test. Only if nitrogen is present, then only we will test for these three functional compounds. Otherwise we will not waste time in testing these functional groups. Okay, now suppose if nitrogen is present, then we have to test for amide. For that, we boil the compound with sodium hydroxide solution, and if ammonia gas is evolved, which can be tested by its smell or litmus paper or Esler's reagent, in that case, amide group may be present. Now, then we test for amine. If this test is given by primary amines, to test for primary amines, we have the azodide test and carbyl amine test. For secondary amines, we have different tests, and tertiary amines, we have different tests. Okay. For that, I'll be covering in some another video. Then we test for the nitro group. So we don't have any specific test for nitro group as such. So first, to test for nitro group, we have to reduce it into amine or hydroxylamine. So nitro group is first reduced to amine by iron or tin, and then it is tested by an azodide test or carbylamine test, as we test primary amines. And then we have the hydroxylamine test, in which nitro group is first reduced to hydroxylamine by the action of zinc and ammonium chloride solution, and then we test for hydroxylamine by silver nitrate solution or Tollen's reagent. In that case, we get a silver mirror or a black PPT of silver. So by that we confirm the presence of nitro group. After we have completed the functional group test, the seventh test we do is the confirmatory test or the specific test, please. That's it. So after we have done the functional group test, so now we come to the specific test, which is optional. So specific test is like, for example, you have 1,3 dinitrobenzene. So there is a special test for dinitro compounds or dinitrobenzene, which is given by you take acetone and add sodium hydroxide. You take acetone, dissolve some compound in it, and then add sodium hydroxide into it. So a blue violet color is observed in case of 1,3 dinitrobenzene. So this test can serve as a specific test for 1,3 dinitrobenzene. So this test also you can do, which is totally optional. Then we have to prepare a derivative of the compound and determine its melting point. So if your compound is a hydrocarbon, for example benzene, naphthalene, toluene, an aromatic hydrocarbon, you can mix, you can react it with picric acid and it form the charge transfer complex with picric acid to form a picrate. If your compound is a acid, you can easily make amide or an ester from it. If your compound is an ketone or aldehyde, you can make 2,4 DNP hydrazone derivative. If your compound is an ester, you can make acid. If your compound is an amide, you can make acid. If your compound is an amine or an alcohol or phenol, you can make ester, such as a benzoate ester, by reacting it with benzoyl chloride. Okay, and then you can determine its melting point to confirm the compound. Okay, so this was just an introductory video, and I hope you guys would have liked it. If you liked it, please subscribe to my channel. I will make further detailed videos of all those tests of functional groups and determination of melting point and boiling point and preparation of the derivatives.